All right, here we go, sixth graders. Welcome back from spring break. We're going to take you through a quick lesson on the surface area of triangular prisms, and we'll look at that again using the nets just like we did for rectangular prisms. However, I'm going to take you through a little bit of a review here, quite a ways back, actually, to where we were talking with two-dimensional geometry and measurement. In fact, this is a document you guys all have access to on Google Classroom from several weeks ago now. And this was before any of our two-dimensional stuff. So if you're doing any of those review assignments on Freckle and you're confused about any of this type of thing here and some of those assignments that are on there, I encourage you to go back and take a look at this notes document. And the reason I opened it up today, though, is it talks about going into how we find perimeter of different shapes. And we know that perimeter is a boundary. So when we think about the perimeter, we think about the fence around the outside of something. It can be measured in straight units, so our units are going to be things like feet or inches or yards, centimeters, that type of thing. And then it talks about area. So we start getting into area, and we're no longer talking about a straight measurement. We're now talking about square units. So in this case here, we have a length of 5 and a width of 3. So there would be 15 1-by-1 squares that would make up the area of this. So when we think of perimeter, we think of a fence. When we think of area, we think about carpet tiles or carpet squares or tiles on the floor, that type of thing, is we're dealing in 1-by-1 squares. Continuing on this document, then, it goes into some of the different formulas that we're going to need for today's work as well, reminding us that calculating area of a rectangle is as simple as base times height, okay, or area of a square, and then actually any parallelogram we started defining as can be area equals base times height, like we see here, but we just need to know how to define the base and height, okay, the height being the perpendicular distance between the two parallel and congruent bases. All right, and then we got into some triangles. It's another reason that this is a super helpful document today. Starts talking about different types of triangles. We're going to see some right triangular prisms today. That's going to be kind of a bonus for us. Or when we have equilateral triangles today, that might save us some work as well. But if you're wondering where we got the formula for the area of a triangle, that is found here as well, where it talks about not only what the formula is. Sometimes we use area equals 1/2 base times height. Some kids prefer to use area equals base times height divided by 2. Either one will get you the same answer. Think about it. Taking half of a number or dividing a number by 2 are the same thing. But here it just talks about how that formula came to be and how we can derive that formula. But it also talks about how we define the base and height of a triangle. And we learned that the base of a triangle can actually be any of the side lengths, but we have to define the height as the perpendicular distance between the side length that we've chosen as the base and then the vertex that is opposite of that. Okay, so we're really looking for that perpendicular line. So on a right triangle, it's a bonus because 2 of the side lengths of the triangle can become our base and our height. But when we don't have a right triangle, then we have to look for this little right angle guy, and we know that's our height because it is perpendicular between our base. It's the perpendicular distance from our base to our vertex opposite. Okay, so again, it gives us some examples. We have those weird ones. Sometimes it looks like the height is outside of the triangle because that's where that perpendicular distance would be to the base extended. And again, this one then took us into compound shapes, which I'm gonna say we're gonna come back to this when we get to our triangular prisms here in just a little bit. Okay, so kind of going back before we get to this triangular prisms, I'm going to just remind you what we did with a rectangular prism last week. We had shapes like this, right, or something like this, where we decided it had faces that were all rectangles. And so when we think about, again, we go back to perimeter as the fence or distance around the outside of something, a two-dimensional shape. The area is the amount of squares it would take to cover it. So we think of carpet tiles or carpet squares or tile floors. Now when we think surface area, we think about actually wrapping this up. We think wrapping paper. So it's like how many of those squares would it take to wrap it up if we were to cover it in wrapping paper without any overlap and without any gaps or holes, right? And so when we unfold that wrapping paper, it goes into something called a net. Now these nets that I have here have these little extra edges on it, but that's so that I can actually tape it back together in that rectangular prism, right? So this was what we worked on last week, was basically unfolding our rectangular prism into a net so that we could calculate that area and say how many squares would there be if we needed to count up the total area of each of the faces. And in this case, for this rectangular prism, there's going to be 6 faces, and each of the two opposite of each other are going to be congruent, which was kind of a bonus when we started calculating these. We knew the top was going to be the same as the bottom, and we knew the left side and the right side were going to be the same, and the front and the back were going to be the same, right? So when we started doing some of our practice problems, this is what it looked like. We're unfolding it, and essentially we're trying to get to a point where we don't really need the net, where we can see like the base of this rectangular prism is a 7x3 rectangle. There's my 7x3 for the bottom and the top, because the top and bottom rectangles are going to be congruent and parallel again, right? And then I have, here's my left and right side. I have a 3x4 rectangle, so 3 times 4, right? So you could see that on the net, or you could eventually probably just take them right out of the drawing. But that's basically what we were working on right before break, which leads us into our triangular prisms. Still a prism. We defined the three-dimensional solids by the shape of their base and the shape of the remaining faces. So these have triangular bases. These were the ones I was kind of teasing you guys during class a little bit, saying, here, what shape is this? And I was holding it in my hand like this. And we said, oh, it's a triangular prism, right? Because it has a triangular base, 2 triangular bases that are connected with 3 rectangles. And then we tipped it over onto its side and said, what shape is it now? And some people started saying rectangular or something or other. No, it's still a triangular prism. It's just not resting on its base anymore. When it's resting on its base, it's a little bit easier to see that it has 2 triangular bases that are parallel and congruent, and the remaining sides are all rectangles. There's 3 rectangles, right? This is one of those interesting ones that we said. It actually has a right triangular prism. There's a right triangle for both of the congruent and parallel bases, as opposed to this one, which actually is an equilateral triangular prism, because all 3 sides and all 3 angles of each of the triangular bases are congruent. And same with this one. It just has a longer lateral face, right? All the rectangles that make up the 3 remaining faces are a little bit longer on this one. So these are some different examples of, again, some triangular prisms. And when we start to unwrap these look a little bit different than when we were unwrapping our rectangular prisms, right? These had 6 sides. If we think about how many sides one of these triangular, I wanted the right one. One of these triangular prisms have, it has the 2 parallel and congruent triangular bases and then 3 remaining rectangles. So when I unwrap one of these, okay, here's that right triangular prism. When I unwrap it, I end up with those 5 sides, the 3 rectangular lateral faces and the 2 triangles that are congruent and parallel. Okay, so again, same kind of idea now. I can take, like we did with our rectangular prisms, I can take all of those shapes that I know how to find the area of, and these were all base times height, because they're all rectangles, and I can add them together to find the total surface area. So here on this one, I do still have 3 rectangles. Here, this rectangle is 1, 2, 3, 4, 5, 6, 7 by 3. This one's 7 by 4. And this one's 7 by 1, 2, 3, 4, 5. Okay, so we have here, we'd have 35 square units. And then here we'd have 7 times 4, so that's 28 square units. And then we have 7 times 3, so that's 21 square units. And because these are right triangles, that's our bonus there. We have the two side lengths that form that perpendicular angle here, those perpendicular lines, those can be my base and height. So I have 1, 2, 3 times 1, 2, 3, 4, but remember the formula for that triangle, the area of our triangle, is base times height times 1/2, or base times height divided by 2. So I have that 3 times 4, which is 12, divided by 2, and there are 6 square units in each of these triangles on the side. So now I would add all those together to get my total surface area. 35 plus 28 plus 21 plus 6 plus 6, right? We can do that right here. 35 plus 28 plus 21 plus 6 plus 6. See, I did 6 and 6 is 12, plus 8, that's 20, plus 5 plus 1, that's 26, and that's 9. So this would be 96 square units for the total surface area of this net, of this triangular prism that we made. Now, this one had that right triangle, which made life a little bit easier for us for a second. One that doesn't have a right triangle, this isosceles, or equilateral triangle, this one happened to be an isosceles triangular prism. Okay, they might look slightly different, but the idea is the same. We unfold it, and then we find the area of each of the 3 rectangles and 2 triangles. But now we might have to draw in that height, or we might have to find that measurement slightly different, just like we did with the different kind of triangles on here again. Either it might be outside of it if it's an obtuse triangle, or inside of it if it's an acute triangle. Okay, but you see how now our net looks something like what we were doing when we were finding the area of compound shapes. Basically, when we were doing this with our 2-dimensional figures, we were just cutting it into 2 shapes that we knew the formula for the area of, and then adding it back together once we found the area of each of those shapes. Then we found the total area of the shape. Same thing now with our triangular prisms. We're just going to calculate the area of each of the faces, and then add them all together to find the total surface area. Okay. So what's that going to look like on today's assignment? Today's assignment is going to look real similar to like last week's before break, right? Where we have the figure, the net, and then your calculations. And one of the things I commented on Google Classroom for a lot of you is I liked how organized you kept your work for your nets or for your calculations. And so I'm going to encourage you to really do that today on this assignment. You'll find this in Google Classroom, surface area of triangular prisms. All right, I gave you a quick review at the top of some of the different things we've seen. Because sometimes when we start mixing triangles and rectangles together, kids can get a little confused. So these are just some reminders here. We've dealt with rectangular prisms a whole bunch now. Different shapes of, different sized rectangles, both on the bases and lateral faces. Triangular prisms, which is what we're really focused on today. 2 congruent and parallel triangles for the bases. The remaining sides, lateral faces, are rectangles. A square pyramid and a triangular pyramid, also known as a tetrahedron. But we haven't gotten to those yet. The idea will be the same. We'll still just kind of unfold them, right, into the, in this case, 5 sides. In this case, the 4 sides that make up the triangular pyramid. It'd be 4 triangles there, right? And we could still calculate the surface area. But today, we're focused on these triangular prisms, right? And so we start you off with one that is a right triangular prism, which is a bonus, again, because the height of our triangle, the base and height of our triangle, are the 2 legs of the triangle that form the right angle. All right, now again, on this net, when we unfold it, and it looks a lot like, right, like this one that we had used earlier, we have our 2 triangles off of the bottom that it's resting on, and that's highlighted in blue for us again there. And then the bottom is also matched up to 2 other rectangles. Now the biggest, longest one is the one opposite of the right angle here. Okay, and then this shorter back one here I have drawn in down at the bottom. But we have all these measurements on here which help us be able to calculate all of these different things. If I focus first on triangle number 1, we can call it this one on the left here. I have a base of 4 and a height of 3. So I'm just going to write that in. I know my formula for the area of a triangle is base times height divided by 2. So now I'm going to go area equals base of 4 times a height of 3 divided by 2. Area equals, what is 4 times 3? That's 12 divided by 2. And what is 12 divided by 2? Well, that's 6. So the area equals, in this case, 6. And now we're dealing in centimeters, so I'm going to say square centimeters. The second triangle, hey, bonus, it's the same thing. If this is 4, this is 4. If this is 3, this is 3. Works the same way on the net. If this is 4, then this is 4. And if this is 3, that makes this 3, which makes this 3, which makes this 3, right? So I can use the same exact calculations because triangle 1 and triangle 2 are congruent. So area equals base times height divided by 2. Area equals 4 times 3 divided by 2. Area equals, again, 12 divided by 2. And then area equals 6 square centimeters. Now I move on to the rectangles. Right, and again, this bottom rectangle might be the one I want to start with. 4 for the length, or I'm sorry, for the width, and 11 for the length. So area for the rectangle now is just base times height. So I can do 4 times 11, which is 44. And that's square centimeters still. Same thing for the next rectangles. I had one that was 4 times 11. I also have one that's 3 times 11 and one that's 5 times 11. You can see the 5 times 11 is the big top one here. 3 times 11 is that shorter back one. So it doesn't matter what order you do them in. Here's rectangle number 2. We'll call that the 3 times 11 one, which is 33 square centimeters. And rectangle 3, we'll call that one the 5 times 11, or the 55 square centimeters. And then to get my total surface area of the entire prism, I'm just going to add them all together. So now I have 44 plus 33 plus 55 plus 6 and 6. I can just call that 12, right? And let's see, what is that? 14, 6, that's 10, that's 14. So 144 square centimeters is my final answer. And then my pen out here. 144 square centimeters is my final total surface area for this first triangular prism. Now, you notice I kind of pre-filled a lot of this stuff in, some of the formulas to keep the video a little bit shorter, but I would like you to write that out in your, you can copy it right off of my sheet here. Pause the video if you need to. But you should have that in your calculations box. Think about how many times I wrote area equals base times height divided by 2. Area equals base times height divided by 2. I knew I was working with triangles. Area equals base times height. Area equals base times height. And by writing that over and over, that really helps me solidify those formulas in my head, and it helps me keep my work really organized. I'm going to do one other one with you before we end this video. I'm going to actually skip the second one because it's very similar to the first one. Remember, the first one had a right triangle, so it was a right triangular prism. And the second one is very similar to that. The numbers are a little bit bigger, but other than that, it is exactly the same. And you can go ahead and use your calculator for some of those numbers. You should be able to fit all of your work still right in here. The third one, though, is a little bit different, and that's because it is not a right triangle. So once again, the height of this triangle can't be the two side lengths, the base and height. You can pick any one of the side lengths for the base, but the height has to be the perpendicular distance from that base to the vertex opposite of it. So they give me a right angle right here off of this base. What is this base? Well, it's the same as this over here, which is 10. Okay, so I have a base of 10 and a height of 8.3 for my triangle. And again, we know these two triangles are congruent and parallel, so I can use those measurements for each one. And actually on this net, I went ahead and drew this in with a dotted line in that same thing right here. Okay, 8.3. So we can see it has a base of 10 and a height of 8.3. Again, for a triangle, see I went a little shorthand there. Triangle, area equals base times height divided by 2. So now I'm going to plug in my 10 for a base times 8.3 for a height, and I have to remember to divide by 2. 10 times 8.3 is actually 83, and I'm still dividing by 2. And then 83 divided by 2 is 41.5. Again, these are centimeters, so my area of that face, of that triangular base, is going to be in squared centimeters, 41.5 square centimeters. And I can just reuse these measurements because the other triangle is the same. Base times height divided by 2, so now I'm going to do area equals 10 times 8.3 divided by 2, which ends up being, again, 83 divided by 2, or 41.5 square centimeters for that second triangle, right? Then move on to the rectangles. These are going to be all pretty easy because this is actually an an equilateral triangle, and it's going to be easy because they all have a side length of 10, and I can multiply by 10s pretty quickly. So they're all going to be 14 here for the length by 10. 14 by 10, 14 by 10. Mr. Green, can't we just do it once and multiply by 3? For sure. I'm just going to, again, keep my work really organized. For this video, I'm going to say area equals a base of 10 times a height of 14, which is 140 square centimeters. And for the second rectangle, I'm going to do it again with 10 times 14, which is 140 square centimeters. And then the third rectangle, which is also 14 by 10, 10 by 14 here, which is 140 square centimeters. And I have a slot for the total here. So now I'm going to add 140 plus 140 plus 140. Those are my three rectangles. And then plus 41.5 and 41.5, which you could have actually just added the 83 back in, right? This would be 0.0, 1, 2, 3, and let's see, that's 4 times 1, 2, 3, 4, 5. 4 times 5 is 20. 2, 3, 4, 5. That makes 503 square centimeters. I have 503.0 square centimeters on there. Oh, I was a little off the screen there. Sorry. So, again, even though this wasn't a right triangle, the process really didn't change. We just had to identify where the height was on our triangle and use the correct base and height and the correct formulas for each of the different shapes that make up the faces of this triangular prism. The last one here, I'm going to let you do it on your own. I'm just going to point out the last few here. There's some pieces missing. First, in this next figure, it shows height a little bit differently. It's showing the height from this base to this vertex opposite outside here. So there isn't really a right angle identified in there to show you that it's a perpendicular height of that triangle, but I did put that in there on the net. And this one doesn't look really like it's drawn to scale, with this being a 4 and this being a 7 and a 7. But we'll go with the numbers that are in that drawing, and it would look, again, a lot like this one that we just did. Okay? But we wouldn't have 3 rectangles that are the same. 2 of them might be the same, looking at this initially, but not all 3 of the triangles, because it's not an equilateral triangle. I'm sorry, not all 3 of the rectangles, because it's not an equilateral triangle for the base. And then finally, this last one, the other piece that's missing here is the net, and that's on purpose. I want you to go ahead and try drawing a net. I see a right triangular prism here. So even though it's oriented differently, it's sitting on one of the triangles where this first one was sitting on one of the rectangles. You should still be able to unfold it and make something that looks very similar to this, right? So this should look, when you unfold it, very similar to this. And again, you should be able to calculate the total surface area of this triangular prism. So good luck with that. Feel free to go back and watch this video a couple of times if you need a little bit more time to see these again. Otherwise, you can always reach out on our WebEx Teams app or through Google Classroom if you're still needing some more help. Okay? Have a great rest of your day.